Hi everyone, welcome back to Travel with an Engineer. This is our fourth and hopefully last episode, at least for now, on Sutter Creek. We already discussed about Amador County Industrial Heritage Corridor, and we extensively discussed about the three sites of this corridor that are located in Sutter Creek. We discussed about Central Eureka Mine, and we had an exclusive episode on Miners Bend Park. But crown jewel of this industrial heritage corridor is Knight Foundry. The Knight Foundry was established by Samuel Knight, who came to California from Maine in 1863. Samuel Knight is an important figure for us for two main reasons. One is he's the founder of the Knight Foundry, and second, he was the first person who came up with the idea of impulse hydro turbines or water wheels. Now, in this episode, we will discuss about the former, that is his role as a founder of the Knight Foundry. But later, when we visit Nevada City, we will have a very extensive discussion on impulse hydro turbines and the role that Samuel Knight played in the development of these turbines. My visit to the Knight Foundry and this episode in general wouldn't be possible without the help of Lindsay Jones and Joe Harrelson, which I'm very grateful for.
Hello, I'm Joe Harrelson. I'm one of the volunteers here at Knight Foundry. I'm on the board of directors, and also I am the site's pattern maker. My original professional background is in mechanical engineering, and I was a professor of mechanical engineering for about 23 years in my career.
I'm Lindsay Jones. I am a member of the restoration and maintenance crew on Wednesdays and also a docent here at the Foundry. I've been here for about 3+ years. My background is information technology, and I retired here and have learned a lot about something I knew nothing about.
The Knight Foundry is a cast iron foundry and machine shop which was in continuous operation for 123 years between 1873 and 1996 before being preserved as a working museum.
Today we have a time capsule because nothing much has changed in this machine shop and foundry since the late 1890s up until the early part of the 20th century.
Reportedly, the Knight Foundry is the nation's last water power foundry and machine shop, where the mechanical power generated by water turbines is directly used to run the machinery without being converted to electricity.
Knight Foundry began in 1873 in Sutter Creek when Samuel Knight bought a part interest in an existing machine shop and foundry that was called Campbell and Hall. And at the time, there were at least 3 machine shops and foundries just here in Sutter Creek alone. The reason for that was the hard rock mining boom that was going on. They had been mining placer gold since the 1849, but as the placer gold, all the easy gold had been found pretty much, and that industry was kind of dwindling, and people discovered that some of the gold was coming from rock, and quartz in particular seams, and so they began to try and mine that. And mining, that type of mining is very industrial. It requires a lot of machinery and equipment. And so all of these foundries and machine shops sprung up to manufacture equipment for gold mining. So Samuel Knight had been working for a while on design for a water wheel. And at the time, either water power or steam were really the only options to power the big stamp mills and stuff that people wanted to build. He came up with a design and patented it and bought a half interest in Campbell and Hall shop so that he could develop his water wheels. And over time, the business grew to the point where they were supplying anything and everything you needed to mine gold, from rock crushers, stamp mills, ore carts, even picks. were made here. And they also made a lot of pipe. And for a long time, that was the primary business. There were many mines in the area and a lot of market for the equipment they were making. But eventually, mining began to slow down, and they were able to begin to serve the timber industry, which began to grow up. And there were, at one point, quite a few sawmills in the area. And so they provided a lot of hardware and equipment for sawmills. The place continued in operation after Samuel Knight died, although Knight seems to have been the brains of the outfit and the one who came up with so many of the ideas, and it became more of a job shop after Knight passed. But they continued in operation right up until 1996 was the last iron pour that was done commercially.
Whenever I visit a museum or a historic site, I always ask myself or a docent that might be available that how this museum came to be. And in this particular site, out of all the workshops and foundries in the region, how this one survived and became a living museum. And when I asked this question, this was Lindy's response.
And probably the biggest reason for that is the people who took over ownership as ownership changed had grown up and worked in the foundry. So there was no outside major influences coming in to make changes. It stayed very much a continuous run of the same people who were taught by the people ahead of them. So it went through, I think it was 3 major ownership changes, if you look at it on paper, but there was very little changed on that until 1970, when an outsider, Carl Borg, came in and ended up taking over the foundry at that point. He tried to make a go of it and was not particularly successful because the market had dwindled to such a point, which is why the foundry basically stopped production in 1996.
And so one of the things that's remarkable about Knight Foundry is that it was a full-on engineering operation. It was much more than just a machine shop and foundry. They had a full line of complete finished products that they did. They shipped stuff all over the world. They had patents. They advertised in trade journals, had sales agents. And originally, in this part, this is the pattern shop here, but originally there was a second floor up above. Unfortunately, there was a fire in the 1930s and it burned, but that second floor was the engineering and design office. And this is where they created the drawings for the various products that they made. Okay, so here we have some examples of drawings that were made here, some of the products that they designed. We have an archive and we have a number of the drawings, and they're really quite interesting. This one, for example, is actually reduced down from its real size. The real drawing is quite a bit bigger. And this is very different than modern engineering practice because they only made this one drawing of the entire machine. It has no tolerances on it, actually fairly few dimensions, and the pattern makers and machinists were expected to fill in the blanks, if you like. They would presumably understand that this was a shaft and a bearing and therefore make it with the appropriate fit. But there weren't any tolerances at all. Also, they would post this drawing up, and then the machinists or the pattern makers would come and measure the drawing and scale it from that. So on modern drawings, you see a note says, "Do not scale." In that era, they did scale it. So normally in modern practice, a thing like this large dredge pump, we would make drawings of all the individual components, but they didn't. They drew the whole thing in one big picture. Here, though, is a single part, and this is typical where someone would come in and want a replacement part or make a one-off piece. So here we have a drawing that was made for a governor. Knight has a patent on governors for water motors. And this one is a little different than the other one because this one does show individual parts and there are more dimensions here. Yeah, and one other thing that's kind of interesting about the drawings, In modern practice, they typically have quite a few signatures of, who drew it and who designed it and so forth. But a lot of our drawings are unsigned. However, the ones that are signed, we determined that the person who drew it was a pattern maker. And all of the names we have from the drawings, they're all pattern makers. And so we think the drafting skills that a draftsman needs are very closely related to the layout work that a pattern maker has to do. Okay, so here we are in the pattern shop at Knight Foundry, and you can see here a series of patterns for different things. This pair of patterns is to make the housing for a Knight water motor, and a pattern is basically a tool that is used to make a sand mold. And then once the mold is made, that's where the iron is poured into the sand mold. So we have here one of the Knight water motor wheels, and this is actually a reproduction that we've made here recently, but this was the smallest size water motor that Knight produced. And in order to make those buckets on there, we needed to make a series of cores. These are some plaster replicas of the cores, and that particular water wheel, it has 12 buckets on it, so you need 12 of these cores, and they're put together to form a complete ring. And the hollow spaces in here, that's where the metal would go in the mold. And to produce the cores, we've got this, which is what we call a core box. And so the core is formed in this box and then assembled into the mold proper. And we have a whole bunch of shrink rules here. When we make a casting and the metal solidifies in the mold, it shrinks. And so your pattern actually has to be larger than the finished casting would be. And so to compensate for the shrinkage, pattern makers use these special scales. They're called shrink rules, and they compensate for that shrinkage. So this silver one I have here, that's a regular machinist scale. It's 24 inches, and all these others, they are also all 24 inches, but with different shrinkage factors depending on the metal that's being cast. So for example, for cast iron, it would be 1/8 of an inch to the foot. So this thing is actually 1/4 inch longer than the real scale here.
Much of the later work that was done at the foundry up until about 96 was work for restoration. Up here, you'll see a column here of wood. This is the pattern to make columns that were on the outside of a store in Old Town Sacramento. Same thing with this other column here. That was all cast, and that's what's up there today. Many people think they're wood, but they're actually cast iron.
After I recorded this episode, I revisited the old Sacramento and found one of the restored buildings that used the decorative items that manufactured at the foundry.
Also, work was done to restore the state capitol. This piece down here is a pattern to make railing fill-ins. So this restoration work were some of the last projects. We also have a circular staircase that was used in a firehouse.
So here on the wall is actually a pattern to cast a decorative piece for a Baldwin locomotive. The Nevada State Railroad Museum up in Carson City was restoring a locomotive called the Inyo, and it had originally been built with a piece like this between the drivers, the wheels. And unfortunately, it had disappeared, so they recruited Knight Foundry to produce a replica. And they made first a wooden pattern and then cast this cast iron pattern from that wooden pattern, and then they used the cast iron pattern to cast a bronze replica of it. And that is to be seen right now up in Carson City. So here we have an Edison dynamo from about 1895, I think, 1890 era. And that was an era in which they had a dynamo located in this particular spot, but we're not sure if it was an Edison dynamo. We don't know what dynamo they had, but this is of the correct age. And this one, interestingly, came out of the library at UC Berkeley and was donated through a series of donations, ended up with us. So here we have the main water motor that powered most of the machine shop, and it produces about 35 horsepower, I believe. And this is a typical Knight water wheel, and this was in operation right up until 1996.
It was recently restored. It's back in function. All it needs now is water, and it will work.
And that pulley up there, that's what drives the main drive line here. And originally, there actually was a drive shaft went across the street to the blacksmith shop.
But right now you have like electric motors?
Yeah.
Yes.
Mm-hmm.
And when you're ready, I can turn it on anytime.
Ah, okay.
Go ahead.
All right.
We're the only ones here, so.
Yeah. Fire in the hole.
Yeah, there's a lathe down here. That's a rather interesting lathe, too. First of all, it's got a rope drive instead of a belt drive. The other thing that's really interesting about this is you notice it's got a headstock at both ends, which is very unusual, to say the least. So this is all one bed. And one of the reasons they had this so long is that when they were making stamp mills, the stems in the stamp mill are really long. And so you need a big lathe. Like that one wouldn't be long enough. This is basically our on-off switch. So you can see I'm shifting the belt from the loose pulley to the fast pulley. So the loose pulley just freewheels on the shaft, and the fast pulley is keyed to the shaft. So by shifting the belt from one to the other, that's how you engage it. And this is actually a very old-fashioned system. In more, maybe the late 1800s, they had clutches instead of shifting the belt like this. So that's actually quite old. That fixture, that is to take an Edison bulb.
As you can see, several driving shafts are extended along the machine shop over all the machines, and each machine can take the power it needs from one of these main shafts, usually via a belt, but in at least one case, as you saw, via a rope. For example, here you can see how this saw is powered by drawing rotational work from the main shaft via this belt. This is the main pulley that originally was powered by the hydro turbine, but now it's powered by an electric motor, and then the main shaft receive their power directly or indirectly from this driving pulley. As you may have noticed, some of these pulleys have a single drum, and some of them have several drums with different diameters. And as you may expect, these different diameters serve for the same function as a gear in your bicycle does. They are used to provide different rotational speed for the machine. So if they have a machine that only operated with a single speed, then they had only a single drum. But if the machine required different speed for different performances, then they could use this mechanism to provide variable rotational speed for that specific machine. While the power required to operate most of the machines came from the main water wheel, there were several smaller turbines that were used to power one or two individual machines that were located in a spot in the machine shop that were not easily accessible by the main shaft. For example, here you see this small water wheel is used to run these couple of equipment and machine on this corner of the machine shop. Or similarly this one. And you can see for this one how the water is provided for this water turbine. It turns out that while Knight came up with the first design for an impulse water wheel, he was not the only one. Many people came up with their own impulse water wheel designs. And in this corner of the museum, you can see a nice collection of some of those designs.
Yeah, here's Knight, and here's Donnelly, and somewhere there's Pelton, there's Miner's Foundry. So a lot of people were making these besides Knight. So this is a Smith and Mills shaper, and basically the tool is going back and forth. This is the cutting tool here, and it's producing a flat surface. This type of machine, this is what was used before milling machines. This was the normal thing to make a flat surface. And then we have over there a similar machine called a planer. And the planer differs in that the work moves back and forth and the cutter is fixed. Now we're in the main foundry at Knight's, and here you can see our two cupola furnaces. In the 1990s, they were using the big one here on the left, but it's no longer safe to use. And more recently, we've been using this smaller one on the right. And basically, this type of furnace, you put a mixture of coal and a little bit of limestone into, it's like a big tube, and set it on fire. And once it's burning, you can turn on an air blast, and it gets very hot. And once it's burning at a good clip and hot, you start throwing in alternate layers of more coke and iron. And it melts iron pretty fast. And you can see there's a spout here at the bottom. That's where we tap it out. So when we start the blast, we plug the spout up with a little lump of clay. It's called a bot. And then once we're ready to tap it, we take some of these long, sort of harpoon-looking things, poke a hole through it, and it runs out into that ladle. And then once the ladle is full, we shove another ball of clay in to plug it off. And our molds are typically spread around the floor here, and we use this crane to pick up the ladle, because iron is very heavy, and go around and fill the various molds. And this crane, they made it here, of course. This machine is called a muller, and you put your sand clay mix into the muller, and then you add water, and these wheels go around and mix it. And then it can be dumped out into a wheelbarrow or taken to wherever you need it. This one is a similar kind of mixer, but this is intended to mix sand that has like a chemical binder in it. So this is a little bit more modern machine, and they actually mixed the sand here on the floor with shovels. And I have an old textbook on foundry work. It says a good foundryman should be able to shovel left-handed or right-handed. And so usually you'd have two guys, one on either side of the pile of sand, and they would just shovel it back and forth and periodically throw some water onto it to mix it.
The sand was a specific type? It came from it?
Yes. It's basically, here is some that's kind of dried out. It's called green sand. You notice it's not green. The reason it's called green sand is because there's some other foundry techniques where they have a lot more clay and less sand, and then they bake it. And you know, with ceramics, they talk about greenware. It's hasn't been fired yet, so this has not been baked. And it gets black. If we're doing iron, we actually put powdered coal into the sand. It makes a better surface finish. But we're mainly doing aluminum, and so aluminum oxide is what makes it black. It originally was kind of tan colored, but as you use it over and over, it turns black. Oh yes. Yeah, so when you make the mold, you know, use the pattern to make the mold, and then you pour the metal in, and the mold is destroyed. So you have to make a new mold for each casting. But one pattern can make hundreds, thousands of molds. And the sand can be used for a long period. Eventually you need to, typically what you would do in a commercial foundry is you would get rid of maybe 10% of it every 2 or 3 weeks, you know, if you were doing production run, and just keep adding new sand. And then we have another kind of sand that has an oil binder. It's kind of, you can see it here in this bucket. It's kind of red colored. We call it Petrobond. And so Petrobond, you don't need to recondition it with water all the time like the green sand. And it captures really fine details. So for like artwork and stuff, they like it. But it gives off a lot of smoke when you pour, and it's expensive.
How many people worked here in Peak?
Well, it seems to have fluctuated quite a bit, but those insurance maps I talked about, they said 35 people were working here. And what we know for sure is that some of them, they had other jobs, and when business got slow, they'd go do that. So Dan Ramazzotti and George Chisholm, both pattern makers, Ramazzotti eventually owned it. They had a planing mill where they made like wood trim for windows and doors and stuff right on the other side of the creek. But it wasn't part of this. It was separate that they owned. And they also built houses. Oh. So apparently, if business was slow, they go build someone a house.
Outside the machine shop, there is also a nice collection of some of the machines that were used in the machine shop, or some of the components and equipment that were manufactured by the foundry. For example, these are the gate valves that were manufactured here at the foundry by casting. These are the machines that were used to manufacture pipes. They were called pipe roller. These are horizontal boring bars that were used for a lace. This machine was called a night sacrificer, and it's used to make paved roads. And its function was to prepare rough and uneven road surface before its final grading. As you can see, it was designed to be towed by a heavy tractor. The museum also have a functioning blacksmith. This concludes this episode. Obviously, I strongly recommend everyone to visit this living museum. For mechanical engineers, particularly those interested in manufacturing, it can't really get better than this, as I'm sure you noticed. And last but certainly not least, again, I would like to express my profound gratitude to Joe Hurlston and Lindsay Jones for their generosity with their time and their deep knowledge of this foundry. So, as always, until next episode, please continue reading, learning, and visiting wonderful places. Thank you. Bye.